Hello everyone, this is Lesson 7, Unit Rate as the Constant of Proportionality. So your essential question is, what is another name for the constant that relates the measures of two quantities? So what we're learning today is another name, and if you've read the lesson title, you can already kind of guess that it's going to be called the Constant of Proportionality. So there's a little hint to you for when you do your summary on your own. Okay, let's look at an example about deer population. So wildlife conservationists are concerned that deer population might not be constant, there's that word constant, across the national forest. The scientists found that there were 144 deer in a 16 square mile area of the forest. That sounds pretty important. In another part of the forest, the conservationists counted 17 deer in a 13 square mile area. So something you need to be paying attention to are those labels that you keep hearing. It's comparing deer to square miles. So keep that in mind as you're reading problems like this. Yet a third conservationist counted 216 deer in a 24 square mile plot of forest. So do they need to be worried? Well, I think they would need to be worried if it was, higher amounts of deer in one area and lower amounts in another. So what we're really looking for is the consistency. So why does that even matter, though? Why does it matter if the deer population is not constant? Think about that for a second. Pause it if you have to. I think it has something to do with either food supply or overpopulation. Maybe there's damage to the land. So it could be that the deer, they're higher in one area, lower than another. So maybe there's something wrong with an area if there's not as many deer. So let's go ahead and compare all these numbers and see if there is a constant. So what is the population density of deer per square mile? So we want to know, that's a hint to you right there. How many deer per square mile? Let's go ahead and fill in the numbers. So we see that in 16 square miles, there's 144 deer. We see that in 13 square miles, there's 117 deer. And then the last one is that in 24 square miles, there's 216 deer. Pay attention that miles are the X and deer is the Y. I really want you to pay attention to that. The X and Y are now going to come into play, okay? We've been labeling them on a lot of our tables, and today we're going to actually need to know the X and the Y. Now, I want you to divide each one of those and see how many deer there would be in 1 square mile. Go ahead, pause it, divide each one of those, and tell me, we can even kind of like extend the box here, tell me how many deer are in 1 square mile. Okay, pause it and solve that. Okay, when you divided all of those, did you get that the population density was 9? Did you get 9? It should be 9 deer per square mile, and you can fill that in on our kind of makeshift box here. I'll go ahead and redo that a little neater. So in 1 square mile, there's 9. It was actually the same for all of them. So that is called the constant of proportionality. That constant of proportionality is called K. K. So that's 9. Explain the meaning of that in this problem. Well, that's basically right here, that there are 9 deer per square mile. It is the number of deer per square mile. Okay, and now that's the unit rate. It's also called the constant of proportionality. We've referred to it as the constant multiple because I was always multiplying by 9 to go from the square miles to the number of deer. We can figure out the unit rate using this little formula here, y over x. We're going to use this y over x. See, that's actually what you did up here, by the way, when you did 144 divided by 16. That was y divided by x. So there's just a little hint to you where this y divided by x is coming from. Let's figure out how many deer there are for each square mile. Go back to our chart here. Square miles, is that the x or is that the y? It is the x, okay? So when we fill this out, let's go ahead and figure out what the answer would be. So we have y over x. I want you to do this off to the side. And we know that for 207 square miles, that's our x. 207 square miles, that's our x. Now, we don't know how many deer there are, But we do know that when we divide them, we get 9. We do know that if we divide the number of deer by the square miles, we get 9. If you're feeling adventurous, pause it and try to figure out what that number would be. Okay, hopefully you realize that you actually need to multiply 207 times 9. We're working backwards here. So another way that you're going to see this written is that y is equal to the constant of proportionality. So I'll slow down and explain that. Here's y, the number of deer, is equal to 9, the constant of proportionality, times the number of miles. Well, in this case, we know the 9 is the constant of proportionality, k, and we know that the square miles is 207. So if I multiply those two, I will actually get the answer, and hopefully that's what you got over here. It should be 1,863 deer. Now, if you go back here, if you divide 1,863 deer by 207 square miles, that should give you 9. Okay, so I know that it might look kind of weird, this formula here and this one here, but it's actually the same thing that we've been doing when we've divided to find the constant multiple. Okay? All right, if that part was confusing, make sure that you ask, but that's how you figure out how many deer there would be in 207 square miles. Okay, now what if we want to know how many square miles you would find in which you would find 486 deer? Let's add 486 to the table. Now, is 486 the x or the y? It's the deer, so it's the y. So we're going to even extend our table just a little bit more. And we're going to put 486 in for the deer. Okay, now you figure out what this would be. How do you figure out the square miles? Okay, you can pause it if you have to. Hopefully you knew that you would divide, so you need to go ahead and divide 486. Okay, I'm going to have you pause it and solve that right now. B124. Yeah, go down to B124. Okay, so 486 divided by 9, and you should get 54 square miles for 486 deer. Now, if you do y over x, we know that y is the deer, so 486. We don't know the square miles, but we know that it equals 9. So again, you can think about how you would solve that. 486 divided by a number gives you the unit rate or the constant of proportionality, 9, and it is 54. So 54 goes in here for the square miles. Okay, now you don't need to write all this down, but it's basically just saying that in order to solve this, it's the deer divided by the miles, the square miles, and that will give you 9, the constant of proportionality. If you want to pause this and write it down, feel free. Okay, moving on to the vocabulary. You can write this down. I'm actually going to let you skip this one right now. You're going to hear that phrase more once we use equations and in algebra, but please write down the other ones. Please write down what a variable is, a unit rate, and the constant of proportionality. And you can see here that those are actually the same thing. Unit rate and constant of proportionality are the same thing. Okay, example 2. You need what? So Brandon came home from school and informed his mom that he had volunteered to make cookies for his entire grade level. I'm sure you've never done anything like this. You've never gone home and said, hey, Mom and Dad, this thing is due tomorrow and we have to do it right now, even though maybe you knew about it before. Well, this is the situation Brandon is in. He needs all these cookies tomorrow. He needs 3 cookies for each of the 96 students in the 7th grade. He and his mother determined that they can fit 36 cookies on 2 cookie sheets. So what we're going to do is try to figure out, all right, if we can fit 36 cookies on 2 cookie sheets, how many cookie sheets are we going to need to make all of these? So please underline this, though. He needs 3 cookies for each of the 96 students. So that doesn't even really tell us the total, but we can figure out the total. And they also gave us a rate of 36 cookies per 2 cookie sheets. So 2 cookie sheets gives us 36 cookies. Using that same unit rate or constant of proportionality, the constant multiple, go ahead and figure out how many cookies you would need you could fit onto 4 cookie sheets. So first figure out how did you go from 2 to 36, or you can do y divided by x to tell you your multiple. So like I said before, go ahead and divide that. And now pause it if you need time, and then uncover when you are ready. 72. Okay, go ahead and try these ones. Try 10 and 16 and see what you get. Okay, so keep this here, keep this in mind for later. We're going to come back to these in just a minute. Hopefully you figured out that we can divide to find the unit rate, or how many cookies fit on one sheet. You should have divided to do that, because 2 sheets are 36 cookies, and we can figure out how many cookies for 1 sheet. Okay, now 96 students need 3 cookies each. Let's figure out right now, because we're probably going to need that later, figure out how many cookies we need total, and that's 288 cookies. So let's keep that in mind. We're going to be using that later. Okay, is the number of cookies proportional to the number of cookie sheets used? You should say yes. The number of cookies per sheet is 18. 18. Hopefully when you did y divided by x, you got 18. Okay, since it is the same for each pair, so every time I divide it, 72 by 4, 180 divided by 10, 36 divided by 2, every time it is proportional. So the unit rate, y divided by x, hopefully you're like, okay, this is feeling pretty repetitive. You keep saying the same thing. Yes, y divided by x, 36 divided by 2. Unit rate is constant of proportionality. It's the same thing over and over and over. So the unit rate is equal to 18. 18. So you see it here. It's called constant of proportionality, unit rate, and the constant of proportionality is 18 every time I divide. So if I do 72 divided by 4, or 180 divided by 10, or the original problem of 36 divided by 2, every one of those is equal to 18. Okay, on the next page, I want you to try this on your own. The constant of proportionality just means that there's 18 cookies per sheet. Now, it takes 2 hours to bake 8 sheets. I want you to figure out how long it will take them to make all of the cookies. Then figure out if they start at 4 o'clock, when will they finish baking the cookies? Okay, pause it and try to come up with the plan of attack for that. If it's 2 hours for 8 sheets, first you might need to figure out how many sheets you need total. Okay, go ahead, pause it and go for it. Okay, how did you do? Did you write down, we know that it's 2 hours to bake 8 sheets, and if you go back, you know that I need 16 cookie sheets total, because that's the 288 cookies that I need. So if 2 hours gets me 8 sheets, then how many hours for 16 sheets? That would be 4. 4 hours to bake 16 sheets. So at what time will she be done? Or they. Brandon's going to help his mom, of course. 4 p.m. plus 4 hours equals 8. So they will finish at 8 o'clock p.m. Way to go, Brandon and his mom. They just made 288 cookies. Okay, example 3. Suzette and Margot want to prepare crepes for all the students in their French class. A recipe makes 20 crepes with a certain amount of flour, milk, and 2 eggs. They already know they have plenty of flour and milk, so they're not really worried about the flour and the milk, but it looks like they are worried about the 2 eggs. So 2 eggs makes 20 crepes. That's pretty important. So 2 eggs for 20 crepes. They want to make 50 crepes. So let's see if they have enough eggs. Let's figure out how many eggs that they're going to need. Okay, if 20 eggs makes 2 crepes, then how many crepes can I make with 1 egg? If you're good at your math or your, equivalent ratios and equivalent fractions, you can see that that's being cut in half. So that would be 10 crepes for 1 egg. So the constant of proportionality is 10 because that's the unit rate. Remember, constant of proportionality, aka unit rate. So what does the constant of proportionality mean in this problem? Right here, it's 10 crepes per egg. So 1 egg is needed to make 10 crepes. All right, pause it and figure out how many eggs you need to make 50 crepes. I know that you can figure that out. Go ahead and figure that out now. And did you get 5? Good job. That is our last example. And tomorrow in class, you can write the summary in your own words, and we will do the independent practice. Great job.